So here there's three functions given to you, f, g, and h, and you're asked to find compositions of them. A, B, and C are just asking for numerical values for the compositions, and then parts D, E, and F are asking you for the formula for those compositions. So I'm going to do D first, and then kind of go back. So for part D, it's asking you to do f of g of x. And so what you do is you put the formula for g inside of f, or you treat it as the input variable for f. So this means that you're doing f of g, which is 3x. But then f would tell you that that is 2 times the input variable, 3x, minus 1. And that is 6x minus 1. So this means that for part A, if you want a value from the composition at -3, you could do this in two ways. You could evaluate the composition, the formula for the composition at -3, and you'll get 6 times -3 minus 1, which is -18 minus 1, which is -19. So that's using this formula that we just found for any arbitrary input value for the composition. The other way that you could do this is kind of like a pointwise sense. You could actually compute what g of -3 is, which is just -9. And then you can put that value into the formula for f directly. So f of g of -3, well, g of -3 is -9. So it's f of -9, which is 2 times -9 minus 1, which is -18 minus 1, which is -19. So you get the same answer. But if you're just asked for the value of the composition, this is an easier approach. But if you need its formula, then you can get this for any value. You don't have to do the in-between step if you know what its composition is in general. So there's two ways you can solve this. Similarly, so let's do the other function. So say h of g of x. Well, g is 3x. So you're computing the function value from h at 3x as the input, but h is, that means it's x squared plus 1, so it's 3x squared plus 1, that's the input. And if you square this, you get 9x squared plus 1. And there's no questions here about asking you for an output value here, but you could easily compute something like h of g of 1. For instance, you could put 1 to the formula here and get 10, or you could find g of 1 separately and then put that value into h. Either way. Okay, and then decomposing functions as you're doing for question 3 here. So you have to have g is the inner function and f is the outer. So inner, outer, you have to follow this order just because it's given to you that way. So one possibility for g, I think the natural choice here is to have the inner function be 4x plus 3, and then the outer function would be x squared, because you're kind of following the order of operations backwards. Or I guess forwards, really. You're doing 4x plus 3, then you're squaring the result, so your inner function could be just 4x plus 3 and you squared. And if you compose these, you should get what you started with, f of g of x. Well, g is 4x plus 3, and you can see that this works, because then if you put 4x plus 3 into f, where f is the squaring function, you get 4x plus 3 squared, and that checks out. So these would be your two answers. Part B, again, there's kind of a natural choice to pick for g. if you have something in parentheses here, it kind of hints that that should be the inner function. So g of x could be x minus 1, and if you pick that for g, then your outer function, well, first you're squaring that value, and then you're doing 2 times that value, and then you're subtracting 8 from everything. So this could be your decomposition, and if you check this, this will work. You would do the same thing that we did in the last part. Part C, again, there's kind of a natural choice to pick here. G could be x squared plus 7. And then what are you doing to that? You're taking the square root. So your outer function would just be the square root. And if you compose these, f of g of x, well, this is f of x squared plus 7, but f is a square root function. So this is the square root of x squared plus 7. And that would be your decomposition.